Look up at the night sky, and you're seeing just one galaxy, the Milky Way. But across the universe, galaxies come in many different shapes. Some have elegant spiral arms, others are giant glowing spheres, and some are chaotic star systems with no structure at all. So what types of galaxies actually exist? Galaxies come in all shapes and sizes, but astronomers have found a way to organize them. Using a system developed by Edwin Hubble, known as the Hubble sequence, galaxies are classified based on their structure and appearance. There are three main types: spiral galaxies, with their iconic swirling arms; elliptical galaxies, which are more rounded and smooth; and irregular galaxies, which don't fit into the other categories. This classification helps astronomers study how galaxies form, evolve, and interact with one another across the universe. Now let's begin with one of the most recognizable types of galaxies: spiral galaxies. Spiral galaxies are defined by their flat, rotating disks and the long arms that wind outward from their centers. These arms are filled with gas, dust, and billions of stars, and they're often the regions where new stars are actively forming. At the center of a spiral galaxy lies a dense region called the galactic bulge, which contains older stars and usually surrounds a supermassive black hole. The spiral arms themselves aren't solid structures. They're more like waves of higher density moving through the galaxy. As gas and stars pass through these regions, the gas compresses and triggers new star formation, which is why the arms appear bright and well-defined. Two famous examples of spiral galaxies are our own home galaxy, the Milky Way, and our nearest large galactic neighbor, the Andromeda Galaxy. Together, galaxies like these help astronomers understand how stars form, how galaxies evolve, and how structures in the universe grow over billions of years. Within the spiral galaxy family, there's an important variation known as barred spiral galaxies. Instead of having their spiral arms begin directly at the center, barred spiral galaxies contain a long bar-shaped structure of stars stretching across the middle of the galaxy. The spiral arms then extend outward from the ends of this bar, rather than from the central bulge. This bar plays an important role in the galaxy's structure and evolution. It acts almost like a channel, helping to funnel gas toward the central region. As gas flows inward, it can trigger new star formation and feed activity near the galactic core. A well-known example of a barred spiral galaxy is NGC 1300, which clearly shows the bright central bar with sweeping spiral arms emerging from each end. Because of this distinct central bar, and the way the arms connect to it, astronomers classify these galaxies as a separate subtype within the broader spiral galaxy category. While spiral and barred spiral galaxies are defined by their rotating disks and sweeping arms, other galaxies lack this structure entirely. These are known as elliptical galaxies. Unlike spiral galaxies, elliptical galaxies do not have disks, spiral arms, or complex structures. Instead, they appear as smooth, rounded collections of stars that range from nearly spherical to more stretched, oval shapes. Because of this, astronomers classify them based on how elongated they appear. Most elliptical galaxies contain very little gas and dust, which means they form far fewer new stars compared to spiral galaxies. As a result, their stellar populations are typically much older, giving these galaxies a more uniform and reddish appearance. The stars inside elliptical galaxies also move differently. Rather than orbiting in an organized disk, like in spiral galaxies, their motions are more random, moving in many different directions around the center. One famous example is Messier 87, a massive elliptical galaxy known for hosting an enormous supermassive black hole at its center. This black hole was famously imaged by the Event Horizon Telescope collaboration in 2019. Elliptical galaxies may look simple, but they are often some of the largest and most massive galaxies in the universe, frequently found at the centers of galaxy clusters. But galaxy shapes don't always fit neatly into just spirals or ellipticals. Some galaxies actually sit somewhere in between, forming a transitional type known as lenticular galaxies. Lenticular galaxies have a central bulge and a disk structure, similar to spiral galaxies. but they lack the bright, well-defined spiral arms. Because of this, they often appear as smooth, lens-shaped systems when viewed from a distance. Like elliptical galaxies, lenticular galaxies usually contain very little gas and dust, which means star formation has largely slowed or stopped. Most of the stars we see in them are older, giving these galaxies a more subdued appearance compared to active spirals. Astronomers often classify lenticular galaxies as L0 galaxies because they share characteristics with both spirals and ellipticals. Studying them helps scientists understand how galaxies may evolve over time, possibly transforming from spiral galaxies after losing the gas needed to form new stars. And finally, some galaxies don't fit neatly into any structured category at all. Irregular galaxies lack a clear structure or symmetry. Instead, they appear chaotic and uneven, with scattered stars, gas, and dust spread throughout the galaxy. Because they often contain large amounts of gas and dust, irregular galaxies can still have intense regions of star formation. Astronomers believe many irregular galaxies may have formed this way due to gravitational interactions or collisions with other galaxies, which can disrupt their original structure. One well-known example is the Large Magellanic Cloud, a nearby irregular galaxy that orbits our own Milky Way. Irregular galaxies may look disordered, but they play an important role in helping astronomers understand how galaxy interactions shape the universe. Yet these four types are only the foundation. Out in the universe are even stranger galaxies, rings, collisions, and distorted systems that defy simple classification. And the deeper astronomers look, the more mysteries they uncover.